Okay, we are looking at 3 to the x, 4 to the x, 1/3 to the x, and 4 to the negative x. 1/3 to the x, you should be remembering, is the same as 3 to the negative x. So these should be all related to each other. So first I'll graph 3 to the x. 3 to anything to the 0 is 1. So all of these curves go through 0, 1. 3 to the 1 is 3. 3 squared is 9. Okay, 1/3, 1/9. So all of these basic exponential curves look pretty much the same, just like all parabolas are basically just the same. So that's 3 to the x. 4 to the x is the same, except it rises even faster. By the time you hit 4 squared, it's already way off the curve at 16. It dips down further to 1/4 and 1/16. It doesn't go below the axis. I'm just exaggerating a little bit so that I can get there. But so 4 to the x is, let's just say that these all through 0, 1. How is 3 to the x related to 1/3 to the x? Let's see, I'll make that one purple. 1/3 to the x, they all go through 0, 1. 1/3 to the 1 is 1/3, 1/9. 1/3 to the negative 1 is 3/1 to the 1. So that's just 3. So this is basically the same as 3 to the x, the red curve, except backwards. So here we go. Okay. Okay, and the relationship with 4 to the x is going to be the same. So 1/4 to the negative 1 is 4. 1/4 to the 1 is 1/4. So it's basically the same as 4 to the x, but backwards. That was easy. Okay. E to the x reflect across the x-axis. Notice people get this confused because x-axis does not mean horizontal. X-axis is a vertical reflection. So it's negative on the outside. Remember, all vertical motion is outside the function. Okay, and then left is inside. So plus 4, not minus 4. Some of you screwed that up on the first homework. Okay, y-axis is horizontal, that's inside. So e to the negative x, and then up. So add 3 outside. So remember that, quick note, all horizontal stuff is backwards from what you think. So okay, 6 to the negative 2/3. Remember that this means flip, and that 6 to the 1/3 means cube root. So this is flip, cube root, and square. So flip, cube root, and square. Next, 5th root, fourth power. So be careful with this because you have to read it sort of backwards. Okay, cube root, and then flip fifth root and cubing. Okay, so the order doesn't matter, just as long as you're cubing there. Okay, so 4 to the x plus 3, remember that that is the same as 4 to the x times 4 to the third. Four cubed is 64. And we can do the commutative property of multiplication. And let me just, yeah, that was a big times sign. Let me just do a dot. All right. If a function can be linear or exponential, which one is this? Linear, you're adding at a constant rate. Exponential, you're multiplying. Okay, so let's see, what are we doing? This is adding 5, this is not adding 5. Is it multiplying by something? Yeah, it's times 2. And we're timesing by 2. So notice that what I have is 5 times 2 times 2 times 2, etc. And so that means that I'm looking at 5 times 2 to the probably x. You need to make sure you haven't got an offset for x. So let's just check by plugging in 0 and see if it gets. So 5 times 2 to the 0 is 5 times 1 is 5, and that is what I wanted. So 5 times 2 to the x is actually what we want. Start with 500 bacteria, double every half hour. Doubling question. What do I do with the half hour? One other way to say that is twice per hour. So if like 3 hours, we want 6 times. So I think not just 2 to the t, I think 2 to the t times 2. Or 2t, of course. 40 minutes is 2/3 of an hour. So we just type in and I forgot to bring my calculator home, so I have no idea how much that is. Sorry, oops. Okay. What we do is we graph the function. This is 500, and we want to figure out where it hits 100,000. So my suggestion is graph, reset, So graph y1 is 500 times 2 to the 2x. It has to use x's. Yeah, the xt theta n, the t is only in parametric mode, so don't use the t. Reset, oh, so y2 is the 100,000. And then reset the window. Let me erase that and write it somewhere useful. I need to be able to see 100,000. So let's make y max in the window to maybe 150,000, and then do calc intersect. If you don't know how to do that, ask me during class. Another way, we can do it by hand. We can say 100,000 equals sorry, that's a 2, not a t. There's the t. Okay, divide by, sorry, 500. Divide by 500, we get 2,000, let's to forget the calculator. 1,000 divided by 2 is, or divided by 5 is 200. So I need logarithms, log base 2 of 200. And remember that you can change the base into dividing by the old log of the old base. And again, I forgot the calculator. Oops, sorry. Okay. What does x to the 5th and 5 to the x look like? Well, x to the 5th quintic looks like this. 5 to the x, again, like the front side, looks like everything else. It comes closer to the x-axis than that. Let's try that. Okay. Let's do 0, 1. It crosses, but then I'm going to have to draw it very vertically. It doesn't go backwards, but it's much steeper than x to the 5th. It actually crosses twice on its way towards glory. So 5 to the x eventually grows faster than x to the 5th. Okay, so where do they intersect? Well, clearly x to the 5th and 5 to the x definitely intersect at x equals 5. 5 to the 5th is pretty large, so you've probably got your window still set to 100,000, so you'll be able to see it. But at 5, that's that second intersect. If I graph them and do calc intersect, I want to guess something significantly less than 5. So when it goes to guess 1. What is it? It's actually 1.7649. There you go.